So for the past couple episodes, I've been working on a test suite for my virtual machine and implementing it in GD script for Godot, the game engine. And I also have an implementation in J and Pascal. Um, I've made a bunch of little virtual machines over time in different languages, and those two of them were the ones that were the most evolved at the time that they've started converging into this thing I'm calling B4 virtual machine. And you can see on the screen here, this is one implementation of, make it go small. This is one implementation of a BIOS for the virtual machine, kind of a Forth-like language. You can see all the words that are defined, and if you say, well, you can put things like, I think you can say 15. Can you show the stack? Probably not. I don't think there's a way to do that right now. But you can hit the backtick button. You get this little debugger. It's all graphical. And there's the stack. So I typed, that's the data stack. So it has the number F on it and the number 60 on it. I'm not sure what number I typed. Oh, that's not good. Let's try that again. So if we say, I think I typed 15, right? Maybe not. Hopefully I typed 15. So if I type 15 and hit a space, and I say put in, I should say 15. But it's not 15, it's 15, right? I say, what is it? FF on the word. Okay, so it's in decimal. The plan is to put everything in hexadecimal for various reasons, because the assembler uses hexadecimal. But anyway, so there's really not much to see here. At this point, this is way too big. You can't see anything anyway, but let me make the screen a little bit smaller. Things, appearance. Still probably too big, but anyway, if you say as soon as you hit a space, I'm hitting space, not anything else. And as soon as you hit a space, it like takes the word and then executes. That's the idea behind this thing. It really doesn't have enough words to really do anything. You can type the word words, and it shows you all the words that are defined. So free, malloc, put n, put the number, word, question mark, string equal, exec. There's no way to type a string in though. So there's no way to type a string into the prompt here. Exec, words, e name, put s, by, comma, decrement, increment. I think if you say like to ink, and then you say put in, yeah, then it shows you one more than that. But you've lost it now. So, and I don't even have a word to duplicate it, right? So normally you would say dupe. Oops, dupe. But that word does not exist, even though it's built into the virtual machine itself. It's a opcode. The shell here does not expose it. So there's really just not enough information on the screen to. There are not enough words in the dictionary to really do anything useful with this yet. But so this is called the style of language where you define words and each word is one token and there's no parentheses or anything like that. The language family is called Forth, Forth, and so that's part of the B4. At least where the 4 comes from. And so there are very common words, and there are many Forth dialects. Anyway, I'm kind of rambling here. So I have this big complicated thing, but it had all the graphical debugger I just showed you, and all there's color on the screen and whatnot. But I need a version of it that just runs through standard input and output. And so what I had just done like minutes ago, or earlier today, let me pull up what I just closed in my browser here. But if I go to github.com tangent storm d4, and then somewhere underneath here we have Pascal, PAS. Just wonder what that is. Oh yeah, I actually wrote the original version of this in Turbo Pascal a long time ago. So you can see no op, get C, and so on. So this was the early start on the BIOS that mentions Turbo Pascal. Anyway, so in my last commit, did I not push it? Wait, I think I clicked on the wrong thing. Oh, I see. This is that. Yeah, got it. All right. So the last thing I did just now, I hide this somewhere on the screen. I do want to make my head tiny. Then, yeah, so I changed the makefile a little bit. I added this new interpreter, and I added hardware concept. So I introduced this thing called b4.term. The unit is a unit of compilation in Pascal, and we assign it to a particular kind of term, the KVM term. So I have you might have seen my JKVM stuff, one of my streams before. I have some terminal interaction stuff that does the color and whatnot. Free Pascal actually ships with one of those, and what I learned to program with in Turbo Pascal 100 years ago. But I have a modern version, and that was originally created in Pascal, and it's called KVM. And so the KVM stuff is, makes the screen nice and pretty. But I need to bypass all that. I don't want all the ANSI escape codes flying around, and I don't want the graphical debugger. I want a line-based debugger that operates over standard input and output, so that I can talk to it from my test suite. So that's the goal here, and I wrote the bare minimum here. You can see it's unit before. You don't have to say input and output, but that's like ancient Pascal syntax, and I just kind of like it. It uses the string utils right now, so you have a string, and str and token are strings, and then done is a boolean. It defaults to false, and then while we're not done, and it's not the end of the file, the standard input, then read a line into that string, and then split it into tokens based on where the spaces are. And for each one of those tokens, check what the token is, and I don't need to begin and end here, and then do one of these things. So this actually passes the first couple tests. So you quit, or you print the data stack, or you print the control stack, and that's the format. And then the next step would be actually put some data on the data stack and then try and print it, and of course this is going to fit. So that's where I'm at right now. And so the next thing I'd want to do is get access to the stack and push something onto it. And there's a function that does that, but the test, well, as soon as I import, I need to say uses UB4. So there's UB4.pass, which is right down here. And because it included this KVM stuff, well, KVM wasn't meant for this dual notion of sometimes using standard input and output, and sometimes just taking over the screen. And so as soon as you import this, it takes over the screen, and that's a thing that needs to be changed. But rather than change that, I just removed the dependency on it. So this is, wait, what? I'm expecting this to not be there. I could have sworn I took that out. Interesting, interesting. Okay, well, I don't know why that happened, but I don't know why that's like that. This is actually a little too small for me, so I mean too big for me. So I'm gonna change the appearance, make the font a little bit smaller, about 16. Hopefully you can still read this. That's about right. Okay, well, okay, I don't actually know. Maybe I haven't fixed the problem. Run. Say make run I. Oh, anyway, I was going through the diff. So, not that you've seen the original, but you know you can tell it's a fairly small program. And basically, what I did was I created. I took a bunch of stuff out of this B4 unit and I moved it into a new unit called. Well, I'll just bring it up on the screen. So U hardware. The idea is that, yeah, sure, why not? The idea is that we have virtual hardware devices for this virtual machine, and one of them is the terminal, you know, the text console. And you can see that we've got these little operations. So those previously were baked into this version of the virtual machine. And kind of the idea behind B4 is that you have an assembly language that has these very primitive opcodes, you know, 2-letter opcodes. So we've got like term go to, so go to move the cursor to a particular place, set the attribute, write a character. I forget what R does. We'll see down here. R reads a key. K checks to see whether a key is available to be read. S clears the screen. L clears the line, and C gives you the position of the cursor, so you can, like, you know, store it somewhere and then later you know, put it back to where it was with the go to. Anyway, so what I did is I these were all the opcodes that were like baked into the machine. You can see they're you know, dswap is swap the last two items on the data stack, and dpop takes an item off and, you know, hands it from B4 to Pascal, or the host language, whatever it is. You'll see this over and over again for all the implementations. So you can see basically I've commented out everything and replaced it with OK. It does nothing. And then I've got, so this is kind of like a dumb version of the terminal, that all it does is, the only thing it will actually do is print out characters. And then there's a real version of the virtual terminal that does this, which does the full thing. It's basically uncomments those. And I moved over anything that was, these are old functions that I needed for Turbo Pascal. You know, like I said, I originally wrote it in Turbo Pascal, and I was wrapping the like ancient Turbo Pascal interface to the screen with my modern stuff. And in my modern stuff, I have this notion of Xmax and YMax, and the old one was, oh, that's interesting. It should be called YMax, not Max Y. It doesn't matter because it's commented out. And then GoXY is not actually used either. That's only for Turbo Pascal. That's never called directly GoXY. And I don't think I'm ever going to use Turbo Pascal again, because it only runs on DOS. And it was kind of fun to go back and use it, but now if I want to go back and run on DOS, I would just use free Pascal because I got that working DOS box. Anyway, so this is probably dead code that just gets removed completely, but we'll see. Anyway, so the point of this was that now I have a way to, you know, so here's the virtual machine as it stands, and these opcodes, these bytecodes, were like hard coded to do the things that I moved to those files. And now I have this notion of a term that is a object. It's an instance of a class, and so I can, you know, I can give it that's a very simple one by default. And so now this file only depends on UHW. And I think these two things can go away, right? Make run. Yeah, everything compiles fine now. And so I didn't need that that link in the interface. Okay, so now when we're in here, we can say Q to quit. Right. So the idea was that the B4 program gives you that nice graphical thing, and you're launched right into the fourth REPL, and it's going to have color and all that stuff. The BIOS, basically, what I call the BIOS, and then this run B4I will be the interpreter for, you know, like a debugger based interpreter that just gives you the basic notions. So it only has the you know, what is the data stack, what is the C stack. So that's where I'm at, and maybe that was a little bit more explanation than you guys needed, but that's where I'm at. All right, so let's let me commit those two changes I just made. I'll do the UB4 one. Clean up old turbo junk. Minor cleanup. Yeah. Okay, so now we want to run the tests, and somewhere around here, I think I had a window where I was running the tests. If not, we'll just make it here. So yeah, so my tests are still in LearnTris, but I made some changes to LearnTris. So LearnTris is a test runner for running, that was designed to test Tetris, but I've made some changes to it that allow mostly these little changes up here, so you can change the input path or actually this is if you can't talk over standard input. And you need to skip some lines so that you can set these environment variables. And if you have a test plan that's in a different place other than the LearnTris test plan, then you can do this. So now I've got a test plan in the plain old B4 directory called b4.tests.org. And basically we got some commands to talk to the debugger, which is where the question mark P and question mark D for data and C for call stack and so on. And then the opcodes I've narrowed the opcodes down to these: add, multiply, subtract, divide, modulo, shift, and or XOR, not, equal, less than, duplicate, zap, which is pop, swap, over, which takes the second item and makes a copy of it, copies the top item, swap, over copies the next top item, CD and DC copy from the data stack to the control stack and vice versa, or I guess from the control stack to the data stack and vice versa. Some more debugger things that have to do with the instruction pointer, the ability to write directly to RAM so we can do our own like handwritten assembly, and then load a byte, load the next byte into, put it on the stack, write a byte, read a byte, arbitrary places in memory, given an address on the stack. Oh, why do I have two copies of RB? Interesting. Okay, well. I'm not sure. That's kind of interesting. They test different things, but they're yeah. So basically, we have a way to like inspect RAM at a certain point. We can read an integer, so read 4 items at a time, or 4 bytes at a time, little endian, and then write an integer, and then these are some complex operations that I've never actually used, but my intent is to use them for array programming. So basically, read X is it's like keeping a counter, and you've got an address. You've got an address in memory that can be referred to with a letter. So I call that the X register, A register, B register, and so on, all the way through the Z register, and then there's extra ones. And so the X, Y, and Z are special because they have these ops associated with them, and basically they allow you to do streaming operations where you're reading an integer from memory, and then you put it on the stack and you increment the counter. So then the next time you read the next one and so on. That's a fairly, it's same as all these operations here. So load an integer from a particular address, and then from that address, read a new integer. Yes. So put the control code for control X on the stack, which is like number 25 or something like that, I think, or text. I don't know what it is. And then read an integer from that address. So now so it's containing a pointer, and then you read from that pointer. And so now we read that data, and then we're also going to increment the address. So do it again. Put the control X on the stack again. Duplicate that. Read an integer from there. So add 1 to it, and then write it back. Right. So address value write integer. Anyway, ry is the same thing, and then wz is like the it does the same thing with the z, but it writes. So it writes to an address. So basically, you're reading from you're looping through 2 arrays in memory, vectors in memory, and you read x and you read y, and then you do something, and then you write z. And if you do that in a loop, then you will, for the length of the vector, then that would be some kind of array operation, like adding 2 vectors. Okay. So anyway, I have these are the tests I have. This is not the complete virtual machine. Like, it doesn't test any of the input-output stuff, and it doesn't test. I kind of got my idea on this like one complex memory operation that's going to replace all of these little operations, or can do the work of these. And so I don't know. I haven't fully made up my mind on that, and there's still some design work to do on it. But in the test, these tests are going to be turned into like a suite of challenges, a game basically. And I think these are complex enough already, and I think maybe it's not so these are already complex enough already, and the thing that's more general, the one op, would be a little more general, but and more flexible, but it would be even more complicated. And I think this is easy enough, so, or this is like as high as I want the complexity to go for the lessons. And so that kind of brings up the idea that there are different things you can plug into this machine. Same thing for the terminal code. So like you're able to plug in different operations by attaching hardware to it. And so you kind of depending on the hardware you attach, there's a set of opcodes that are reserved for talking to that hardware. And so that's kind of the idea behind swapping out the terminal. So now I can just use a very simple standard input, standard output only terminal, and then we should be able to run these tests. And I think so I have all these tests passing under the new GD script version. There's nothing to see on the screen. There's nothing to I'm not testing the terminal, like I said. There's no input or output, but like the logic is working. And so now I just want to get the J version and the Pascal version in sync, just for my own use, because the Pascal version can compile the JavaScript and WASM, and so that's one way to get them onto the the web. I'll probably write a JavaScript version as well. Whatever. But right. And then the J version is kind of like the official spec, and that's also out of sync because I want to get them together. At some point, I'm going to make a scripted video and like on my main channel, and it's going to present this virtual machine. And I don't know. I already use J, so I don't. You know, for most of my videos on that channel, so I probably will use J heavily. J is certainly the most flexible, and it has a better KVM implementation. And you know, I'd like to get that working. I'm rambling. Anyway, let's get today's goal is to get the test working here. So let's go ahead and cd learntress, and I've made a little test script that pass before.sh that just configures everything I need to configure. So it actually ignores that. It just says the test plans are in that before test, the test we were just looking at. Switch over to the Pascal directory, make b4i, and then use it as the program to test, which is going to be, I think I'm going to call this org test or something like that, make it org spec or something, make a new tool, a new repository, and everything separate from learntress. Anyway, but that's a story for another day. There's a lot of changes in Pascal, so I'm using this KVM library was made for an older version of free Pascal, and now like getting all these errors, so I'm going to have to go back and fix that at some point. But I'm not worrying about that today. They're all just warnings, and I will clean them up, you know, before this goes live or whatever. But and they're also in a different repo, so maybe I'll even just strip out that thing and make a smaller thing, kind of. Not really sure. Anyway. Okay, so basically the tests that I am failing are, I've passed 3 tests and then IO hex has failed because I'm not able to print out the stack in binary. So let's replace this with print, just print stack, print ds, and we will make a function called, or procedure, print ds. How do we say print stack? Pascal wants you to do what they call Pascal case. It doesn't. It's actually case insensitive. And so we need a stack, right? So which stack do we use? We say I want to switch to v4.pass. So as I said, I wrote this in Turbo Pascal. I didn't use any kind of object-oriented programming or anything like that. So not this one. I want ub4.pass. b4 is the program, and ub4 is the unit. So like a module, or that's the word for. So data stack is a stack. So type stack equals. Okay, so S is a stack, and the Emacs mode for Pascal has this nat electric indent. There we go. We can turn that off because it does not indent the way I would like to indent. Just look at that. It like move this way over here. So S stack, and we'll even just put a prefix to the string. It's still indenting really good. Oh well. A bit bigger today. Okay. So what do I want to do? I want to say write this, and then write len this. and then we need a for the v value, which comes out of UB4. Oh, I need to say UB4. V, and we'll just say UB4 value. You don't need to, but I prefer that. Interesting that Rightland is not known as a common name. All right, so then we say for v in, is it in? Yeah. In S2, and we'll just say begin and first boolean equals false. I want some kind of like string join, but there isn't such a thing. So if first, then begin, first equals false. No, wait, if not first, if first, then first equals false. Yeah. If not first, oh, no, we say else. First and first equals false, else write, and we're going to write a space. And then what is the format? I think you write, I think the format string, so free Pascal format string. Format string number. What I want. What do I write? It's like Python, I think. Yeah. How do I do it in hex? X. Oh, so it's basically like Python. Is it capital X? Capital letters? X, and then so we write a dollar sign and then the thing. I don't know if I want to keep the dollar signs in the output, but so I want to write FF and CC, right? And then this is going to be uppercase. I don't know. Oh, it looks like it is uppercase by default. So good. Then write V, and that's it. And then we're going to say print stack. So write prefix. Write prefix. And so we're going to say print stack. You don't even have to be consistent with your capitalization. You can do like that if you want. It's totally fine because it's case insensitive. I don't like that. And I don't like the keyword begin. So I want to get rid of that. And basically turn this into Oberon, right? I have an intention to write a Pascal compiler on top of this virtual machine. That's one of the reasons I've written in Pascal right now, right? In this dialect of Pascal, so that in the future I'll port it to the my Pascal or Pascal dialect. It's really Oberon. Oberon is a language in the same family. So anyway, we're going to call this ds : space, and then we're going to pass in the data stack, which right now is ds and rs. Oh, interesting. In this machine, the data stack and the return stack are completely they're part of RAM. That's not the case in general. In fact, it shouldn't be the case. Each CPU needs to have its own machine. But this one only has one CPU. Okay. So anyway, you can pass that. So yes. I guess you'd say that, right? Maybe we pass in a pointer to a stack, yeah. So S is the pointer to a stack. So in S in, and then we'll pass in this. And I think the same thing here. And then we should pass these two things. Now, this may or may not work. Let's see. What happened? Syntax error expected. Okay, so we go to line 5. Because I put a colon at the end. I want to edit that. What am I calling pass before? So in interest pass before dash. So is that not how you write a shell thing? Like that, right? Yeah, there we go. I thought you could do that with a double pipe and get OR behavior. Or I guess maybe exit isn't the right thing to do. All right. Anyway, so now it won't try to run the test if the compilation fails. Syntax error. So print stack, but oh, because this needs to be a semicolon. And this should be the word string. Stack. Type p stack equals you can't just make an anonymous pointer to something. You have to give it. Identifier not found CS. That's because it's called RS. Return stack. Okay, look at that. Diff from expect. Because it's just the area and RAM. Well, first of all, it didn't format it, did it? Right, this. It's not the same as Python strings. You want to switch it around. So it's X colon. X. What? Oh, I see. Format is 12. Okay, so yeah, you have to write it like this. I could have sworn. there was a better way. It's right str. Free Pascal. Right str is the different function. No, it's not. Okay, I guess it just has a very different style format. It uses sysutils. I'm gonna guess. Okay, but that still is not what I want. There we go. But now, in addition to that, the other thing was that there's a stack pointer, right? So data stack pointer. There's nothing that tells me how many items are on the stack. Maybe reg dp is that. Reg dp. Okay. So actually, I want I integer and equals 0. If I equals 0, then that's correct. If I is greater than 0, then write that. That's what I want. If I equals 0 to reg to count. And you even have to say if count is greater than 0, then try equals count to begin. And we want RAM. No, we want S of I. Count integer. And then here we're going to say data pointer, the reg data pointer, reg data pointer at, whatever that is, reg return pointer at 60 and a semicolon dispute. And on line 13 something's wrong. Local variable v is not used. Okay. Wrong type stack in array construction. B is equal to S of I. Stack expected long int. Value S is a pointer to a stack. I want this. Oh, okay. So now, otherwise, we say else. Does it like else? Either word is fine. Else case toke. So you must say if it is hex. Free Pascal is hex. There's no testing. How do I test to see if it's a... Yeah, I think you got to do this. I bet I have an is hex somewhere in my library. If it is a hexadecimal token, then dput was string to hex. Is that what I just said? Oh, string to hex. Hex to. No, maybe. Hang on. What if it fails, right? Oh, okay. So we can actually just try it here. This is in sturdy util, so I have it. Else, if else put hex, whatever. So I'm gonna make a thing called put hex. That's gonna return a boolean. So put hex toke. So else if put hex toke, then okay. Just like pass. Right? It's not a real thing. Procedure okay. I define that in the library that I use. That I'm trying to do. Actually, it's defined in EV4 maybe. Didn't it? Okay, that should be EV4. So procedure. Whoops. Put hex. Toke is a string. begin end. So try hex to deck, dput hex to deck, except copy step on the pascal try except. So yeah, on class type do except on do result equals false. Try result true. Do I just say begin here? Yeah, no, statement list is fine. Result equals true. And so this is not a procedure, but a function. And returns a else if put hex, then okay. Else, right, then what does toke mean? Isn't that what does that mean? Didn't fail. 25. What's wrong with that? And hex deck required some number of dput hex to deck of s of the token. I think this requires an end. There we go. I printed an extra 0. I equals 0, then for I equals 0 to count, do is it 1 based? Is that my problem? Okay. Okay. If toke 0, how about else if toke equals, then okay, ignore it. Else if toke 0, so if there's too many like spaces in a row, that's fine. Toke 0 equals, this is gonna be a pain to write, 4 quotation marks in a row. Then, actually, we're gonna do a case here. How about begin? If toke equals 0, then continue. Case toke, I know that's valid. I don't know, Pascal. Valid pre Pascal. Pascal, old school Pascal did not have that. Else, we're going to say case toke 0 of Right, and then so this is going to be one header in the case statement. Oops. Okay. And then we're going to do something for backticks. Okay, and we're going to do something for, so these are, so quotes are care literals. These are control care addresses. But we don't need to worry about that yet. We just need to get literals working. So, and then, okay. Cursor doesn't go where I want it to go. And then we say int for the nested case. And so what we want to do here now is we'll say push. We'll just say dput toke1. We'll dput ord of toke1. So if you put a quote A, it's going to put like 65 up there. Quote capital A is whatever the other. Oh, okay. Oh, that didn't work. Note a lack of second space after the so if I say the length of the string, 3 Pascal, that's Sterling, right? And this is Sterling toke equals 1, then dput ord space, else short string expected p wide care. And 38. Okay, well we just put 32. Space. Else. Short string expected p wide care. 38. Length. Again, it's one based. Hate that about this version of Pascal. Pascal lets you define whatever indices you want into an array, but all right, so I got that passing. Now we need the control characters. Same thing here. Really, it's the same thing, but Then I'm gonna make a function called error invalid backtick and invalid control care, and then you know what it is. Else if ord toke2, I don't even have to say ord toke2. If ord toke2 is greater than, I don't have to test all this right now. Do test this. All we have to do is really put ord toke2 minus ord of this, and we're going to say uppercase, pre-Pascal upcase. Yep. And then we want to put 4 times this. Test this against other weird against chairs out of range. And then error is just procedure error s string. Yeah, it's still indenting. I think this is an old mode in Emacs, and you just put up with it. I don't know. Anyway, it doesn't matter. Begin. And maybe if I write a Pascal mode, I have to write a new Emacs mode for it. 29, rightland string, rightland s, and then halt. Okay, add 2 top items on the stack failed. Oh, because we don't have that. Okay, so then before ops apps. So now so this gets cleaned up every time I edit. Yeah, so do not edit, regenerate with make table.pass. So ll wrong directory. Maybe I didn't change anything yet. I think if I change it parses this file and like looks for this little chunk of code and then generates the reverse or the lookup table. But that's for mapping a name to a thing. So I want the UV4 b4, no, ub4 ASM. Okay. I actually don't like this. I normally format my code this way, and in Pascal I kind of don't. Kind of weird. It looks odd to me now. Okay. So now I'm looking at b4 op, right? Hmm. Yeah, I want this. I want this version that returns a Boolean. So we got to put this here. We got to expose it. This is in the interface section. This is the implementation section. This is all one file. I'm paging through it. How do you? Yeah. I have it set up so when it sees that character, it treats them as different pages. So I need to call this. And you can see it says out. So Pascal lets you modify or even not even have to assign the variable that you're passing in. So so then, my goodness. Problem is, okay, so I need to be able to execute an operation on demand. But here it's only set to, okay, so I've got to like write a little wrapper of this. Around this. So I need to say something like, and it even says reformat this function, so I might have a problem here. I need to say like function do function run op and return the IP. So we're returning. Oh, the reg. So okay, we're just returning that. Function run op, and it's going to be op is a byte. Match the indentation. We'll say case op of, and we have to copy all these things. Put them there. And then we have to say, instead of that, we say run op of this. So identifier not found T. No function result types run op. Oh, it's just a procedure. 304. Yeah. Everything still runs. There is a test suite. There was a attempt at a test suite, but it's just empty. So I'm using this universal test suite now. Somewhere in here we have make test. SB for it, yeah. But it's empty. All it does is assert something about registers. I think this was in Turbo Pascal, and I didn't have any kind of test suite at the time, test tool at the time. And rather than making one, whatever. All right, so now run I, and we should be able to say like A, B, C, and then backtick A, and we'll even do backtick A, and then we'll print the data stack. Right? Is that right? Yeah, in hex, because they're hex. No quit. The backticks are register addresses. That's right. Okay, so everything worked that way. And now I have this function called runOp. And if I put that in the interface, then we can move that there. Eventually, this is going to be like a class that has methods on it. And you'll be able to make multiple instances of the same. And I think I have way too many ops here. I have more ops than I actually implement. But the question was, did not modify make opt? Now we need to start procedure runOp, and then do that. Did I misspell it? Oh, we need to compile again. Make P4. Oh, it is not. I think we're working now. And now we should change the op table. PD. It didn't change ops. It changed UB4 ops. I haven't changed any. I just noticed that I had to change it, right? Maybe I shouldn't have expected that to change. Okay, so all right, so just for my own sanity here, let's remove something that we're not using. Divide negative. So negative is no longer a function. And now u before opposite. Okay, so and then in BIOS, do I ever use ng? I guess I want ng space, right? I know you can check for a word boundary or something like that. That's a horrible thing to search for. Okay, so I never use that. Actually, I think this would have failed. Like if I put in like or whatever and put some random thing in there. Oh, okay. Yeah. You force it to run. He does everything. Okay. Okay, but I can actually remove, re-add that for the time being. I'm going to go through and do it in a different pass. I just don't want it all in one commit. Okay, so what change in UV for ops after I put that back? Nothing, because I okay. Okay. What have I done? In interpreter. What's different in there? You could check out that to replace it. GD make off table. What happened there? Oh, that was actually part of the last. Need that semicolon right there, and then and make op table with that pass, and then amend. And then gdb4i.pass. Where I start on debugger interface. Debugger command. Debugger commands. Okay. I'll go ahead and push that. Interesting. Still thinks it's on the old address, but it put it in the right. Oh, right. Has moved. Yeah. So get remote dash. Get remote set URL origin git at github.com and storm .git. Okay, moving on. So I guess now we want to go back to the old directory and run whatever password for us. Sure. Okay. So now, right, that was the point. So then else if now in here, is it, or is it in the assembler? I need to use this. I don't know. I'm not tracking in my head what the names of the files are. So B4I is what I want. And if I go B, then I go back. So UB4ASM is what I need to say UB4ASM. And then here we're gonna check. Come on. I think there's a way. There's like a nicer version of this buffering thing that lets you like it would be nice if switching back to the previous buffer did not have this in it, right? I see some people are watching. I can't tell who's here or who's not here, but welcome. Welcome to the Pascal evening. Before op, feel free to ask any questions in the chat and respond. I see them. Op string out. Op is right. I need to run. That's funny. It's a pun. AD is actually the hex code for AD. Interesting. Oh no, it's not. It's not the hex code for the operation. It's just reading that as a hex code. Maybe it should be the hex code. But no, the things that start with A are reserved for one of the output devices or one of the connected hardware. So A0 through AF are all talking to hardware device 1, and B0 through BF are all talking. The bytes are like opcodes talking to whatever attached to them. You can extend the bytecode by adding machines to it. All right, so at least that's the idea. That's not implemented anywhere yet. In my head, that's okay. So anyway, if UB4ASM, it's not isop, it's. I keep trying to go back and forth. B4op. And so then if the token is an op, then else case token of if it is an op, then we're going to tell the machine to run op. And again, that will eventually be connected to like some object, so there's more than one of them. Okay. All right, so that passed, but there is no shut op. Again, that is one of the first changes I need to make. Okay, so there's no shift op. What am I doing? That's why I have all these like tabs open so that I can keep my context here. So let's open up this and go to B4 pass, and we'll go to UB4 as UB4 just the machine itself. This is the master place for this. Okay, so I have shift left and shift right. And actually, I don't need the J version open right now, so I can open up the ops as well, the assembler as well. So that's in E4 BIOS. No, it's in pass BIOS. Only the Pascal version uses this yet. Oh. Yeah, I don't have this installed. For E3A. Oh, that's my assembler. Why isn't the wait, I'm confusing myself. Oh, B4A doesn't have it, so say B3A. Right, so I do have a very simple Emacs mode for B3A, which is a self-hosting assembler. So it's not quite as powerful as real assembler, but the real assembler has basically the same syntax. All right, so what am I looking for? I just wanted to double check that. Yeah, okay, no NG. What about SL? So I have SL, shift left, and I have SR. Okay, so I can replace shift right. Or I can just, so SL is the only one I actually use, and I just replace it with sh. And then we're going to replace, right. I wanted to leave that in here. I wanted to change this to BIOS. And then over here, this is UB4. This is B4I. Name your tags. Okay, so in here, SL, it becomes shift, just sh. And then this goes away. SR goes away. There was shift left and shift right, and now there's just shift, and it takes a signed argument. I don't actually know what happens in Pascal if you try and shift to the wrong direction. But you should be able to, you know. All right, so over here, let's go to cd verb4 and pass. And I'm going to say make run. Okay. Unknown word should, but try it again. Oh. Okay, so the make op table. It's just doing a linear search through that thing. No, something's wrong with the make file. There we go. Okay, so it knows what that operation. Okay, so uv4.path files. And move ng. Optimal. Okay. Next up. So now this test should run. And it should know what sh is. Now, okay, so now diff from expected. That's here. Okay, so now if v is less than 0, then, or I say if v is greater than or equal to 0, then we'll do what we're doing now. No, actually, how we'll say if it's less than 0, then we'll just change it. If it's less than 0, then v is equal. Oh no, but then we have to write a negative in there. Negative v. Else. I don't think we need the semicolon. Okay, so negative numbers are working. Okay. All right, so run ops before i.path, run ops, and run ops from the interpreter, before I interpreter run ops, and format negatives. Okay, and then now we want to, in order to make this test, what's happening is CD and DC are actually called something else here. So we have, they're called DR and RD, DC and CD, and then we have RD. Let's look for, oh, right here. I'm just going to remove these. And let's make file. Actually, let's just test the words make run. This is going to fail in the BIOS because it doesn't know what DR is, right? In the BIOS now, so we're going to say query replace RD space with CD space. Instead of return stack, it's call stack now. Yes, 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 yes. And the same thing. DR DC. Instead of data to return, it's data to call stack, or data to control or call, either way. Yes, 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 yes. Okay, and then yeah, same thing. Make run. Unknown word RD. Okay, so missed one. Okay. D. CD? That looks weird. Let's see if it runs. Sometimes fourth looks weird. GD bias. Yeah, CD. It was RD, not CD. Okay. All right. So git commit -m pass make file fix op table generator fix make op table rule. Oops. In the make file. Then got too much stuff, work in progress. Isn't get ignored, or it's a little messy there. So let's just GD this. So pass, rename DRRD to DC, rename ops. Okay. And then if we go here, so we have 23 tests pass. Now I would expect more tests to pass. What does $I mean? Which means show the IP address. So print, right one. I should call that right stack, right? Replace string print stack with right stack. And now we're going to say here it's IP, and then I think it's just called IP. Let's make this a function. B format. I should call it B format. B format. And it's v is a value. So it's actually function. And it returns a string. And begin, end. And we'll just take that verbatim. And I think then we can just call v format. Format as hex in v4 style. Result does not seem to be set, right? Instead of calling right, we need to call resort. There we go. We don't need that semicolon. And there is no thing IP. Implicit type conversion with potential data loss from Unicode string to op string. You can ignore that for now. Actually, we can also say is it plus Unicode strings? Op string. Or I'll worry about that later when I clear up the error. But anyway, IP was not the right name. So UB4 UB4. Oh, reg IP. Register IP. And it's even a pointer. It's interesting in Pascal, you know, you're using a native language. Oh, interesting. Right, because here it starts at 0. All right, so in the new version, why would that be the case? Yeah, look at that. Instruction pointer is right at 0. So these are supposed to be these need to, there needs to be 32 registers reserved for the dictionary. The dictionary is a there's a set of ops where you basically you can assign the bytecode, right? And so and that you assign them to the control characters. So like Control C would be, you know, this is the one that handles any incoming ASCII character. Then Control A, Control B, Control C. So Control C is actually at that place. Okay. So that's actually correct. The question is, can I do that without breaking the BIOS? We'll find out. So Where's my UTF-8? UTF-8. I need like my own little map of this, right? So all these control codes are there. So 2x, so yeah, so it should be, instead of 0, it should be 2. Instead of 1, it should be 3. So that's all we have to do. Change this to 2, 2, 2, 2, 3. What's happening? Why am I not? I hit the wrong key. Ah! What's happening is I switched to QWERTY keyboard somehow. And the breakpoint is not at. Okay, that's fine. So that should be 3C, but 340. Did that break anything? Oops, I need to go over here. Oh, it didn't break anything. Interesting. Okay, so I don't want to mess with the real thing that's running the BIOS. So make this test pass. We're gonna explicitly set. The idea is, okay, so you've got these 64 registers. 32 are your dictionary, 32 are reserved for internal use, like the things I was just messing with. And then the idea is that the instruction by default will start at the next address. So the instruction pointer starts at reg IP, starts at 100, or not 100, but 256, slot 256. So you have 64 variables, or 64 registers, 4 bytes per register, so that's 256 bytes. And so then 0 through 255, and then 256 is where the IP address starts, or is where the instruction pointer starts. It's not make run. I want to do this one. Yep, and that worked. We're now into step. So S is step. But let's check that in, because that was kind of a major change. Make run again. Didn't make any difference. Right, so GD v4.pass and v4i.pass. Actually, let's do them separately. UV4 move internal registers to proper place. Place in RAM, and then call this write stack and v4i.pass write stack and format and add I command. Okay, so now we need to step, and that's easy. In fact, I think it's just called step, but we'll call it, say UV4.step. Error duplicate label. Right, because it's not Q, it's S. Six tests passed. what does that mean? Okay, so now if the token is I have to put a semicolon there, yeah. If the token is the @ sign, free Pascal strip, is it right? I think RIGHT, right string. Okay, so right string, starting at the end, left string, I want drop, right? So we want we want to say dput. I think I looked this up earlier. It was hex to dec. It's gonna be a decimal though. Hex to. I should be using like Lazarus. Decimal value. Oh, I guess okay. So that's actually right. And then we want to say right string of toke, and then length of toke -1. So take everything but drop the first character. Okay. Make but we don't want to put it. Okay, we don't want to put it on the stack. We want to write. We want to dump the memory. So dump and an address, right? Is a integer, and not a function, it's a procedure. And we're always going to dump 16. So var I 16, var I is an integer. And then say for I equals 0 to 6. No, for I equals 1 to 16. No, for I equals 0 to 15. Do begin end. Right. RAM. Right. I need to disassemble it too. So this is actually a fairly complicated instruction. We can just do this for now. So that one worked. And then we need to, all right, so if the line, if toke 1 is equal to this, then so I need that same function that I just did. So let's say function read parse address toke string. I always say end first so it doesn't, so the auto indent doesn't screw up the next line. Integer. A integer. What do we want to say? Begin. A equals parse address. Or we'll say we'll call it then put mem or something like that. Put mem string, and it shouldn't be token, it should be string. The string one, and then put mem string. Else all work. And then we say put mem up here function. But it's procedure. Put mem string, and then we're going to say there a integer. Didn't even get down here. So we can say parse address from the toke. I'll call this like dump mem. How about show mem? Show. Then over here, when we say parse address, we get that, return. Result equals, and now for put mem, what do we want? This is not an integer, this was copied and pasted. So we'll say a equals parse address of string, and then toke string, and I guess we need like an I, a and I, and then we say for I, nope, I equals 0, then for toke in split string 2 begin, and we're going to say ram a plus I is equal to hex to dec hox to dec hex to dec of the token. And then I plus equals 1. I think you have to set a flag to make that. Or you can say inc I. That'll work for this. In theory, you should be able to put in to do handle like long integers, handle integers with this byte. Because it does a little ending encoding. All right, what's failed? So on line 50 we have a fail. Semicolon. Line 55 we have okay. Hard to parse this. Looking, you look up here for the word error. Variable identifier expected on line 61. Oh yeah, right. Inc I. This is an invalid integer. Oh, right, because then let's do it like this. If I equals 0, then else begin. And so we have to parse that token, not the whole line. Should work. 160. I made a problem with else. What's wrong with that? Maybe we... Oh, you can't have that semicolon there. Okay. Wait. Right, and now we're printing out 2 lines. And we need to actually say this. So we need to actually print out what it is. So write. All right, we're going to break this into 2 things. So this toke string begin toke equals format, and we said is x. I think we have to say O2x. That doesn't look right. We'll figure. No. Pascal format. Yeah, that's right. There's also a format. Okay. There's also a format string. But I think this is going to work. Does it say hex? Yeah, hexadecimal. Okay. And we will say RAM adder. And I think it complained about that earlier, but if ram, let's just say val I and v is equal to ram adder, and then we'll send v in the format, and then write toke and space, and we'll say if v equals 0, then toke is ... else toke is this. Does put mem actually put anything in memory? Ram a plus I equals hex to deck. Oh, we have to adder plus I. So v should be a byte. V is a byte. This goes outside of here. So it was just always getting the 0. Okay. Or it was always trying to parse that token. Okay. There we go. So now we've printed out A, B, C, C, C. So we're off by 1. Plus 1. We have to add 1 here because it starts at 1, and it should in a normal sane world it starts at 0. Okay, we're good. Ooh, oh, b is an invalid integer, right? Okay. And we'll say we need op is a byte, and we use that same thing here. If op, so what was it? U v4 ASM v4 op, same thing as down here. If the token is an op, then I'm gonna give this a name. Well, no. Oh, okay. And wait. And what then? If it's the case, then b equals op. Right? Oh, we just say b. Actually, we say if not this, we just, then yeah, okay. So if it's not an op, if it is an op, then this thing handles it. But if it's not, then that function returns false, and then we say p equals whatever, and then ram. Okay, so this should work. So now when we're showing the memory, now we also have to show that in the output. So I think when I do these tests, we gotta like what am I trying to say? We got to break this down a bit. These might be too complicated for tests. Definitely, I mean, the two things are happening here. One is that the IP address did not increment. It did not add an extra number to the IP address. Here's the instruction pointer. Let me check some coding. gdb4i.mask. Min b4i read and write him. No disassembler yet. I might even remove this test until the very end. Because later on I came up with a better way of doing things with the backtick addresses. It also occurs to me that I should probably put something in here to run, or to tell you how many tests you have left to run. Record how many tests are left to run in test case or output. So you have some kind of like idea how much progress you're making. I think there's like 30 something. And speaking of that, it is like 9 something here, and I have a little more time, but I'll wrap this up. Let's break this into another section. But just for the sake of it, let's look at the op table. I'm kind of glad. Like I'm trying, and now I'm kind of getting a feel of like how long this is going to take to write. So, I probably like rambled for quite a bit, but like if you were just going full speed, if I were going full speed, I did some refactoring here, but like otherwise, but I skipped over a lot of things that I would have had to write from scratch if I hadn't already implemented the virtual, like a version of this machine. So yeah, this is probably several hours of work. I mean, in a way, that's kind of obvious. Like it's probably like a week's worth of work for somebody to build one of these if they don't know what they're doing. I think that's good. That's a that's a good lesson, right? Good course. You got to give them a lot of hand holding, and it's got you got to have some kind of reward. You got to make it interesting as you go along, so it's not just passing tests, but like you do a little bit, and then you get the ability, you know, show them how to run something on this and do something with what they're building. Okay. Well, what is my problem here? I wanted to. I wanted to know. No, I haven't. Maybe I've duplicated this. Did I? No. Like in v4.pass itself, in the like this is my other debugger, right? I probably have this function. All right, so if this is in this range, yeah. So what you're looking at here, this is a really dense code. This is the display for the what happens when you hit backtick here. So it's all colored, and you got this would say DS and CS, so data stack and control stack. But so it's a disassembler, and this is kind of what I'm trying to get. But this is like a much more advanced disassembler than I want here. You can see like it's everything in cyan here is what I want it to do, but some of the other things like this end token, it's aware of the fourth dictionary and like debug information. So that shouldn't be the case. Or actually, I don't think it's aware of the fourth dictionary so much as it does the assembly. Yeah, I think this is actually a parser. Like it parses the and executes the BIOS in real time. So the like when you run it. So the BIOS is not compiled in, I believe. I could be wrong with it. Yeah. So it actually reads before the BIOS.b4a. So it is an interpreter and is executing things. So so this fancy debugger here, I don't know, it doesn't look like a debugger, but you can move this cursor around, and you can step and press all these little keys here to do different things. Has the word quit twice. It has the word quit twice. Get back to it. And there's something wrong with the formatting here. It's in the window is too small. Make it like yeah. Did I put the letter 0 in there? I introduce that 0? No? I don't know what that 0 is for then. Maybe it was just like a display error. Pretty sure. Yeah, anyway, so you can page around through memory, and it redraws the screen in a funny way. I think it's clearing the screen in between. But you can move around in memory and like see what's been defined from that file BIOS stuff. And I want to make a much nicer version of this debugger, like lots of colors and whatnot. The terminal I plan to use has like true color. But the terminal emulator here has true color, but I'm not exporting from Pascal's point of view the terminal. Or maybe 250. Or I guess I'm using my little tiny ANSI coloring language. So it says background K, and make it black, foreground W for white, foreground Y for yellow. Okay. Anyway, when you step over, that's interesting. I'll have to mine this a little. I would think that the IP. I've lost. The actual failure. There are two failures. One is that we don't execute this. There's no like errors or anything. So LB should be executing this in here. And we should see that in the output. Write to memory at this address LB load byte AB, and tell me at this address what is here. So here's the output. That's what's at that address. And so you see it, there's the instructions. The instruction pointer is pointing at that instruction. You can tell because it's moved. And then after we step is not it increments it one here, and it increments it once here, but this doesn't get run. It didn't print in here. I think this works. Yeah, so now it says in here. So that has to start at 1 or at 0. Huh. Oh, I see what it is. So I wonder if this breaks now. This is still running. Can I go to the IP? So type I get to the IP address. Or structure point. 5 step. I just ran do. So it looks right to me. Why am I off by 1? This seems like a simple off by 1 problem, but I don't know where it is, and my brain is a little. I'm not a little tired. It seems like I ought to know where this is. What's going on here? I just typed by. Why is it? IP. Whatever we're looking at, we run that operation. This is right. This is correct. So now, okay, this one should be I. Why does it? I should get the error I had previously. Where it's not running the. Like if I set this to 101, I would think that works. Well, it doesn't. I think I'm doing something wrong here. I have like a -1. Wrong place. It's here. For I equals 0. Right stack, right. This is memory, right? Plus 1. This is wrong. But this failed somehow. This gave me a problem somehow. So then right mem might have a put mem. Ah, yeah, okay. So why don't we call this -1? I equals -1. Then that was the problem. All right, so the output did come out right, but then this did not get disassembled. And so when we do show mem, we're going to say 0. Toke equals 0, else toke equals this, and then string 8, 0 through. Right now, I think we'll say B7, B8. Then we will say op table. Let's go back to b4.pass. Let's look at the original debugger, op table. This one right here, op table. I hit some wrong key. That's it. And B is a byte, so we just have to say B. Now we have to say toke equals op table. Is op table B. No found op table. No found. UB4 ops. Right? Now I have too many ops. Okay, so that's true. Strip out the ones that I don't need, but 8, 1, 8, 2, 8, 3, 4, 5, 6, 7, 8, 9, A, B, C. I'll make this D, and this one 8E. This one is 8F. This one is 9-0 and 9-1 and 9-2 and 9-3 and 9-4. All right, we don't need greater than. Here. Greater than, equal. Do we have less than, equal? Dang, I use all of them. All right. LT. All right, so how about GE? Anytime we see GE, we can replace that with swapping it and say less than. And so wherever we said greater than or equal than, we'll say MN. I don't know what that means. Something to do with the memory allocator. Okay. For whatever reason, I call it MN in the comments and MS over here, but whatever. The M size. I don't want to debug this right now, but that looks wrong, right? I don't think I'm actually using this. I don't see a plus sign in here. All right, whatever. Doesn't matter. We don't have to test it. Just run it, see if it works. All right, so now whatever so now I can get rid of greater than or equal. And do we have not equal anywhere? All right, so whenever we see not equal, we replace that with equal not. Equal not. Equal not. Equal not. Equal not. I can get rid of not equal. And then we have less than. And then, okay, so now we're not going to have dx, we're never going to have these. And do we have halt? We do use halt. Oh, that's interesting. I guess there's a reason to use halt, right? Because you got to exit the program. But that needs to be like a debugger command. That's going to be an extended thing. Maybe I add halt. The GT. Oh, I got to save that. Make it run again. They're out of order. 3, 4, 5. All right, so now this is 96, 7, 98, 99, 99, but okay, so A0, A0, A1, A2, A3, A4, A5, 6, 7, A8, and A9. So now AA is not code, and then we'll be able to pass that test. It doesn't find GT, why not? UB4 stop pass. What's wrong? What happened here? Like some weird I'm going to get rid of this anyway. Like, I don't need this word, but what happened there? Yeah, there's some corrupt. There's like some hidden byte here. Somehow I was getting the empty space thing, the the control space. Okay. Control space is written like that. Okay. So I think now that this test is going to pass. Yeah. Weird. Oh, it's still it's still looking at the op table because it's still in that range. All right, so in we'll do it like this. We'll just skip over that range. We'll do the B ones. No. Well, we just the B commands are like this test is probably wrong. All right, but anyway, 9F is the range that we'll print. Okay. All right, so now we're talking about control characters. And it's the same kind of thing. I'm going to say O1 through 1F toke equals plus CHR A board of A plus B. So we're going to calculate which character it is. I think this passes. I think we get past. I was thinking maybe the things are out of order. So WB dpop D equals dpop, so the temporary, and then RAM, so the address comes second. Wrong. Test is wrong. Saying the test is wrong. I guess I implemented it the wrong way, but okay, so that is because I should have said ord of this. So I made a mistake when I implemented it. I wrote the test and passed it. Okay, so diff from expected, and this is 1. Okay, so now Oh. Yeah. I think it's right. I think you put the value on the stack and then you say where you want to write it to. That's the more. But I consistently wrote these tests the other way around. Of course I did, because it is slightly more convenient when writing these tests. Like maybe even I don't know, but you want because you say 100, you say address read byte, and then here we're going to say dupe. So we want to swap first, and then read the byte, and that should work. Now I got to go fix the other implement. That worked. We got 34. How many tests are there? I don't know how many tests. I think there's 37. They should. Uh-oh, someone's screaming downstairs. And my battery just died on my phone. I mean, on my camera, I see. And baby screaming downstairs. So I'm just gonna say, I'm just gonna wrap this up. You can see. Well, yeah, you can see where I'm at. Like, I have these little tests to write, and whatever. Basically, the streaming instructions, which I don't actually use. Read byte and read integer. Yeah, I'll wrap this up for now. I'll go see what's going on downstairs. Baby really should be in bed. I just kept doing this way too long. So thanks for watching, and I will see you again